Welcome to module 11.2. In this particular module, we will now go ahead and explain how the symbol table is getting populated, right. So, there are two symbol tables as I had mentioned. There is a global symbol, there is a class symbol table which is global to all the subroutines, and every time a subroutine is compiled, we need to have a subroutine symbol table. Since the scope of that symbol table is restricted to the subroutine, so once we finish that subroutine and go to the next subroutine, the whole all the entries can be erased, and we can use the same structure for the next subroutine where we populate it again. So, the class symbol table is populated once for the entire file. The subroutine symbol table is populated every time you start fresh compiling one subroutine again and again. So, this is how we will we will now see how the symbol tables are populated. Where do we fit in the code? So, we have 13 routines. The first routine will be main. We have 15 routines. The main will call compile class will call other routines. So, each of these routine will contribute towards building the entire executable file, the VM file, and what will happen in each of these subroutines, what is their contribution, that is what we will be presenting. The first thing is that we need to construct the symbol table. We will see which routines are going to contribute for the symbol table. Now, let us go into this. Now, class, right. So, the class basically has if you just see, a class has class name. This is the rule for class. Let us go back to this. The rule for class is that the class has the keyword class, then a class name, then this symbol, then class var dec star, subroutine dec star, then this closing symbol. So, what will compile class do? It will first go and check whether keyword class is there. Yes, it is. If it is there, then it will check for what is the class name, right. Then it will check for the symbol this. Then it will go and see if it is encountering class var dec, because class var dec star means class var dec is optional. So, I may have class variables, I may not even have class variables, my class may not have variables. So, this class var dec star is optional. So, there can be 0 or more class var declaration. So, if I encounter class var dec, then what we will do, what is the rule? If I encounter xxx, immediately I should call compile xxx. So, if I encounter class var dec, immediately I will call compile class var dec, and when this return, I should see / class var dec. Now, I will repeat the same two steps again and again till as long as I am going to see class var dec in the first one, right. So, when I see class var dec, I will call compile class var dec. Then when control comes back, I will see whether I am having / class var dec. Again I will go and check if class var dec is there. If it is there, again I will do, and I will repeat it. Once this is over, then I have subroutine dec, again that is star. Subroutine dec star means I could have multiple subroutine declarations, 0 or more. I may have a class where there are no subroutines also, right. So, again the similar treatment is done for subroutine dec. So, if I see less than subroutine dec greater than that symbol, then I will call compile class compile subroutine dec, and on return I will see whether / subroutine dec is there, and I will keep on doing it. At the end of this, I will go and check for symbol the closing braces. So, this is how compile class will work. So, if you just go back to this routine, so first I see class, so main sees class, so compile class comes. As I told you, first it will check, yes, class is there, then main is there, this is the class name, then the opening symbol is there, then there is one class var dec. So, please note that you are seeing a class var dec. So, immediately compile class var dec will be called. On return, it will check for / class var dec. Then you see subroutine dec repeating two times, yes, subroutine dec, then subroutine dec, and this will again you will call compile subroutine dec, which will process the remaining tokens here, and on return I will see / subroutine dec. Similarly, again I will call subroutine dec, and again I will get back to this. Then finally, I will go and check if this symbol closing parenthesis is there. Now I will return back control to main. The main will now see this slash class there. Okay. So this is the overall structure, right? So all the tokens between say for example classware dec to slash classware dec will be consumed or compiled by compile classware dec. All the tokens between subroutine dec to slash subroutine dec will be consumed by compile subroutine dec. Similarly, this also will be by compile subroutine dec. So this is how the whole thing works, right? Now what will class do? At the beginning here, so actually so this is about checking the grammar, but what will class do in addition? So the compile class, once it is doing all these checking, intermediately whatever I have put in green, and henceforth in this entire module whatever I am putting in green is what is the contribution of that routine to the ultimate virtual machine code that I am generating. So what will class name? So this will initialize the class symbol table. So what is the class symbol table? Class symbol table has three associated integers. One is the static count, which will tell you how many static variables are there, field count, which will tell you how many field variables are there, and total count, which will tell you how many total variable total of static plus field. So all these things are initialized to 0. That means your class symbol table does not have any entry, right? 0 variables are there. Now it will also initialize a global string called current class name, and it will assign the class name that you are seeing here. So you are seeing the class name you are seeing here. I am just moving the mouse there. The class name that I am seeing here, that will be, so the class name that I am seeing here, that will be assigned to this current class name, because we will need this for some other purpose, which I will tell you later. So and so two things the compile class has to do in addition to doing all those checks and calling compile classware dec and compile subroutine, calling them. Specifically for the code generation purpose, it has to initialize the class symbol table. What do you mean by initializing it? The static count, the field count and the total count should be set to 0. Then it has read the class name, that it assigns to another global variable called current class name. It assigns the value class name to that current class name, right? It assigns the string class name to the current class name. So it's a string. So these two are the only thing that the class does with respect to generation of the code. Other than that, it only checks the grammar and calls the corresponding subroutines, namely compile classware dec and compile subroutine dec. Right. Now let us go to compile classware dec. After this, after your class finishes these things, the first thing it will call is compile classware dec. Now so the classware dec rule is that I should see a static or field, then there should be a type, then a variable name followed by multiple variable names. So there will be one variable for sure, but there can be multiple. So for example, I could have static int I comma j comma k, right? So immediately what you do is we check for static or field, first thing, then find the type. So it should be int boolean char class name. Then you find the var name, right? Now add to total count entry of class symbol table. So initially total count will be 0. That means add to 0th entry in the class symbol table. So class symbol table is a array of structures. Each entry will store the kind, type and name and index of the variable. In this case, the kind will be static or field, whatever you have seen here. Then your type will be whatever type you have seen here, int boolean char or some other class name, the name of the variable of course, and the index will be, if it's a static variable, index will be static count. If it is a field variable, it will be field count, right? So you make this entry. The moment I see static, type, var name, something, so immediately you do this entry, right? So index is either field count or static count depending on the kind. Increment field count or static count depending on whichever kind, and increment total count, right? So these two are the things that you do here. So that means an entry is created in this class symbol table for that variable static. So if I have static int I, then I will be entered as a static variable inside. Okay. So if I have static int I comma j, then that comma will be checked here, as you see here, and then again you check for var name. So add to total count entry of class symbol table. So total count is incremental, so the next entry will come there. You add the kind and type that you have seen earlier itself, and the name and index will change accordingly, because now you have the name and the index will be, if it is a field count or static count, that will be, and then you increment the field count or static count and also increment the total count. So and keep repeating this step, and ultimately then you have to see a semicolon here. So this is how class_var dec will work. And what is the role of class_var dec? It will populate the class symbol table completely, right? Right. Now let us see a simple thing here. So ultimately, when your class compiles, it finishes class main this thing, then it will come to class_var dec. Now you see what's going to happen in class_var dec. It will first see it is static or field, it says static, then type is boolean, name is test, so and then semicolon. Immediately this will be entered in the table as kind static, type boolean, name test, index 0, and your static count will become 1. Like that for your field variables also this can be done, right? So this is, and then at the end of this it comes out after checking for the symbol semicolon, then the calling main routine will see whether class_var dec has ended, right, /class_var dec. So this 4 tokens are consumed by compile class_var dec, and when the return comes back to compile class, which is the bounding class here, compile class, it will check for /class_var dec, right. So this is the basic way by which all the class variables. So if I put if this class_var dec can be called multiple times, and each time it is called, one more entry gets added, and that's why we had the class symbol table as a global structure, so that multiple times your class_var dec calls, it will keep on updating that global structure. So to sum up, the compile class_var dec is actually responsible for populating the class symbol table, and this is exactly the code that you need to write, which will go and populate your class symbol table, right. Now after this, if you go back to compile class, after your compile class_var dec, this will now start called subroutine dec. So now the next thing that we want to see here after class_var dec is the subroutine dec. So the subroutine dec rule, if you see, first it will check for constructor, function or method, then it will see if it is void or some type can be boolean, char, integer or class name, then it will have a subroutine name, then followed by the starting parenthesis, then parameter list, then the right parenthesis, and this is the followed by subroutine body. Okay. So this is the rule. So what will happen? First it will go and check for constructor, function, method, then it will check for void or type can be boolean int, then it will check for subroutine name. Okay. Now once I check for subroutine name, at this point these are the things that we do. Initialize your subroutine symbol table, that means your local count, argument count and total count, which is local plus argument, should be set to 0. That means the subroutine table has become empty, right. So every subroutine you restart this table, because every subroutine the scope of the variables are restricted to that subroutine. So every subroutine I start, I will go and restart this symbol table. Now we also name the current subroutine name as subroutine name that you are seeing here, and current subroutine type as constructor, function or method. right. If current subroutine is a method, add this argument class name 0, right. If I am having a method, as we explained last time, if I am executing a method, then before that method is called, the argument 0 for this method would be the class to which this, the object to which this method belongs to, right. So the 0th argument will always be the object to which this method belongs to, this method is assigned to, because when I am executing the method, I will land up with class variables and field variables, and for me to access that, I need an access to the object to which I am this particular variable is associated. So this will be the first argument. So this routine, which holds the pointer to the current object, will be the first argument. So this argument 0 class name argument, that is a 0th argument, and the class name, which will be the type. So that is something that we put on the current subroutine table, and we will increment argument count and total count. Okay. So these three things are done by the subroutine declaration, right. Then it goes and check for symbol. After checking for symbol, it has to see parameter list. It will see parameter list. So it will call compile parameter list. After compile parameter list finishes and the control comes back to this routine, it will see slash parameter list. After that, it will check for end of parenthesis. Then it should see subroutine body. So it will do compile subroutine body, and after subroutine body finishes, it should see slash subroutine body. So this is the overall structure. So let us just go back to this. Yes, after classvar dec finishes, there is a subroutine dec, right. So the subroutine dec will first check its function, yes, and type is void, the name is main, and there is none in the parameter list. We will just see what it is, and then subroutine body, right. So the subroutine body goes till this, and then I come back to subroutine dec, and then there is another subroutine dec here, call subroutine dec, that I finish and then come back and go to class. So this is how. So these tokens are processed. This is how the XML actually gets the token. So coming back here, so these three are the actions that compile subroutine dec has to take with respect to code generation, right. Now, so what will compile subroutine dec do? It will call compile parameter list, and then it will call compile subroutine body. So now we will go and see compile parameter list. What is compile parameter list? It will have type var name comma type var names, right. So this is a parameter list. So right. So whenever I say int I comma int j comma bool k, so I is integer, j is integer, k is a bool, right. So so the parameter list is of this. So please see that there is a question mark here. The question mark essentially says that I need not have anything in the parameter list. For example, as you see here, if you take this particular subroutine declaration, right. So if you see here, this is of, if you see here, main has no parameters, the small main had no parameters. So the same thing is valid here. The same thing is valid here. So parameter list and slash parameter. If you just look at this, there is no parameter at all. It just starts with parameter list, nothing in between, and slash parameter list, right. So what will happen is, the first time I see, I will see type then var name. So, now you can see here so I will have type var name. So, the type the kind of this, since I am in the parameter list, the kind is argument, the type is whatever type we have said here, that will be the type, then the var name, then the index is the argument count. So, then this will be into the subroutine symbol table, and then we will increment argument count and total count. And this will be repeated, as I see comma here, it will be repeated again and again till there is no comma and you end with the parenthesis. So, we will keep repeating this step. So, what will the parameter list do? It will populate the subroutine symbol table with all the argument parameters, and this is where you should fit the code, and this is where your argument parameters get added. Right, and then we, so this is all about parameter list. Once the parameter list finishes, then you go and call compile subroutine body. So, what will compile subroutine body do? Subroutine body actually starts with a semicolon, then there could be 0 or many var declaration, then it will end up with it will have statements, and then it will end up with this parenthesis, close braces. So, what will compile subroutine body do? It will check for symbol, this one, and it will might see vardec. If it sees vardec, then it will call compile vardec. After return, you must see /vardec, right. So, compile subroutine will see vardec, then it will call compile vardec. After compile vardec ends, it should know it must see /vardec, and you keep repeating this till you keep on seeing vardec, because vardec star means 0 or many times repeating of the vardec. So, right. So, this is how it goes. So, I will be calling this compile vardec again and again, 0 or many times, and after that finishes, I should see statements here, right, and immediately we should call compile statements, and the end you should see slash statements. Then you go and check for this symbol, closing parenthesis, and that is where subroutine body ends, right. So, the subroutine body basically calls two routines, compile vardec and compile statements. So, as such you see here, after I finish your subroutine declaration, first I say function void parameter list is over. After that, immediately we call subroutine body. The subroutine body will have multiple var declarations. So, I have one var declaration, another var declaration. Okay. So, I have multiple var declarations. Right, followed by statements, that is what we are saying. So, it will have var, so your subroutine body will have var declaration, var declaration, var declaration followed by statements. Okay. Right. So, this is the entire thing. So, let us go and see what will var declaration do. In the var declaration, again these are the variables inside the subroutine. So, these are local variables. So, the compile vardec is responsible for populating the subroutine symbol table with local variables, right. So, it will see var type, var name, comma var name till semicolon. So, it will say var int I comma j comma k. So, I, j and k will become 3 entries in the symbol table, in the subroutine symbol table. Their kind will be local, their type will be int, in this case, and the index will go from 0, 1, 2, and that value is that count is actually maintained by your local count. Okay. So what will compile VARDEC do? It will check for var, it will then check for var name, then add to total count entry of subroutine symbol table local type name and local count, increment local count and increment total count. Okay, right. Right. So this is what compile VARDEC do. So at the end of this compile VARDEC, as you have seen, we are now completely populated our class symbol table and the subroutine symbol table. This is exactly where you need to fit in your code and populate this, right. So in the next module, we will now go into the next part of thing, which we call as code generation. Thank you.